Go for it.
Okay. Well, I definitely have some tough acts to follow here. Last, hopefully not least, here today to talk about Montecristo, which has been recently released by datastax for use by the general community. So what I'm going to do is talk about its features and how to run it, and also I have to talk about the collection process that you need before Montecristo. So I'll go over those things. Just a few things about me. From University of Illinois originally, electrical engineering. First job was at Oracle Corporation. I was on the team that rolled out Oracle Financials. Had my own company in Chicago for about 20 years doing Oracle stuff. Then I was CIO for a few years at a global training provider. And then in 2012, I started Rhinosource in the Bay Area and focused on datastax, Cassandra, do a lot of architecture, data modeling, load and stress testing, health checks, upgrades, everything Cassandra and everything datastax. And key partners, datastax. I work with a company called InnoMinds that does managed services globally. Axonops is a partner of mine, and AWS, key partnerships. Overview of this presentation, just going to do a little bit of history of the product, talk about building and deploying the collector, which is very important to be able to run Montecristo, and then installing and running Montecristo. I'm going to try to just make this not too boring because it's super detailed, but I'm going to try to, I put all the details of the presentation in my presentations on GitHub, so I'll try to stay higher level. But basically, covering the diagnostic collector, DS collector today, it's an Apache license on GitHub. And then Montecristo, also Apache 2.0 license on GitHub. So both open source products we'll be covering today, which is appropriate for the Apache conference. So the history, Montecristo was originally created as an internal project at the last pickle, and John was on that team and contributed a lot to this product. So I didn't want to gloss over the history. I did read the history file. And then datastax Professional Services took it on after acquiring the last pickle and then enhanced it, and that's what has been published to GitHub today. So the authors and contributors credit, I wanted to make sure that they were shown on the slide here. The datastax diagnostic collector in the first half, and then Montecristo, large team, a lot of the last pickle staff. So definitely a lot of good work's been done for this, and we appreciate having access to this. So kind of going over the overall process, what are health checks? What is a cluster health check? It's basically periodic analysis of cluster configuration performance, highlighting problems that need to be addressed. How does it work? Well, we collect diagnostic and configuration files from all the nodes in the cluster, and then we run this set of automated scripts, Montecristo, on the diagnostic information, which are contained in what we call diagnostic tarballs, or some people call them snapshots, or support bundles, datastax support calls them. But basically, gzip files of log files, configuration files, metric files, all from every node get pulled together, and then we run Montecristo on that to then produce an output deliverable, which is a report, which has recommendations, immediate things to fix, near-term things to fix, long-term things to fix. Then it goes into a bunch of detail about all the stuff. So a couple stages, you need to run the collection process first, and we'll go over that first in detail. Second stage, we then run Montecristo on the information collected. And then stage 3 is you got to fix the issues. And then you would want to repeat this process every 6 to 12 months just to see where you're at, make sure you're fixing the problems. And datastax used to do this for customers, but now companies have to do it themselves, which is what I'm doing in this presentation, or partners like us can do it for you. So kind of drew a graphic of the overall process just to have a picture and not all words. So over on the right we have Cassandra cluster. We run the DS collector, which connects to all the nodes. So it has to have it has SSH access to all the nodes. It actually pushes down some collection scripts, runs those, collects the data together, creates a gzip file, and then sucks those back to the collection machine. Which then, so now you have a set of diagnostic tarballs, one for each node. And then those are the input into the Montecristo process that you run, and then a health check report is produced in HTML format. A really big report, it could be 100 pages or more. This is what the report looks like. Back then I closed it. Oops. let's go back. There it is. So it's a HTML report. It looks pretty nice. It actually is a web server that is opened up at the end of Montecristo that you use to view it. But it has many sections, and we'll go over those sections in a minute. But it's created HTML. You can save it as a PDF, and then you can use Word to convert it to Word if you need to edit it. But it's quite a big report. It has a lot of sections. At the very top, there's a summary of findings with immediate, near-term, and long-term recommendations, things to fix in the cluster. Then there's a more detailed infrastructure overview recommendation section, lists the nodes with settings they have, storage configuration, operating system configuration, operating system limits, and it's node by node, so super detailed. In fact, I should open up, maybe down here, the link to it. I'll open up a real file in a minute. But then the data model goes through replication strategy, all the tables, indexes, unused tables, GC grace settings. It's a very exhaustive set of information in this report. Really, it would take you, maybe days to go through and do this manually.
3 weeks.
3 weeks?
It used to take 3 weeks.
Okay, so this process, even though it's quite elaborate, still you can get this done in a matter of a few hours as opposed to 3 weeks. So it's quite valuable. So yeah, it even does Astra guardrail checks if you're thinking of converting over to Astra from an installed cluster. It'll give you, if you've got certain things that are outside of Astra's guardrails, things you'd have to change in order to use Astra.
And that works with 4.0.
What's that?
The 4.0 guardrails, it watches for that too.
Yeah,
it'll look for any guardrail and say, oh, if you're going from 3 to 4.
Okay, I didn't even realize that.
Yeah.
Okay, all right. So stage one, kind of going into a deep dive of the collection process, the first stage. So it's focusing just on the collection part, where we're going to suck all the data off of the cluster nodes and create the diagnostic tarballs. So deploying the collector, there are multiple steps. You have to actually get the source. And I got kind of stuck here because I was, so you download the source, and I was actually trying to run the source, but you can't run the source. You actually have to build the product. You have to build the collector first. And so I did this on Mac OS X, and I was trying to do it on Linux, and I ran into some trouble. So I found that building the collector was much easier on my Mac, so I did that. And when you build this collector from the source that's easy to download, you have to make sure that you have Docker running on the machine. And then once you have it builds this DS collector tar.gz, then you transfer that over to the machine where you're actually going to do the collection. So you can actually do the collection and Montecristo on the same machine, but you don't have to, because the collection machine has to have access to all the nodes. But once you collect all the tarballs, Montecristo just needs the tarballs. So Montecristo doesn't have to be connected to the nodes. So they could be different machines, is the point. So then building the DS collector, download the source, like we said, uncompress it. There's two environment variables that you have to set. There's one you have to set the issue. You can just make up whatever number you want, but you have to set this variable to build the collector, because it actually puts it in the name of the collector. And then if you're running this for DSE, because this process will work for either DSE or Cassandra. So if you're doing for DSE, you set this environment variable is DSE equal to true. And then again, making sure Docker's running on the machine you're building the collector on. And then you just do make, you go into the unzip directory, do the make, it builds the collector. And then once it's done, you just deploy that to the machine where you're going to do the collection from. And that machine you're going to collect the tarballs has to have access to all the nodes. So then running the DS collector, so we have a built collector now. Now we deploy it to machine. It can be Linux or Mac. It doesn't matter. I test them, run it on both, and it works fine on either Linux or Mac. So you can imagine, like, if you're building this collector on your Mac, but then in your environment you have a Linux VM that you needed to run that had access to the nodes, you would then just have to get your built collector to that collector VM so it could run and see all the nodes. And it has to be a standalone machine. You can't run this DS collector on any of the cluster nodes. It has to be its own machine. And it has to have SSH access to all of it. It's going to collect from. And I found that the SSH user that the collector connects to on each node should have sudo to get all the information to get the most amount of information that it can get. It'll still collect what it can, and what it can't get, it'll tell you warnings it couldn't get certain things, but it'll gather more of the OS information if the SSH user has sudo privilege. It could be root, it could be Cassandra, it could be another user. That's part of the config. And it'll work with systems deployed on Docker and on Kubernetes as well. It's just part of the configuration. You can do that. So we transfer to run it, transfer the collector to the machine that's going to run it, uncompress it, go into the collector directory, and then there's this collector.conf file. This is where you just have to configure the collector for your environment. And if you have your own custom directory locations for log files and config files on your nodes, you configure the settings in this collector.conf so the collector knows where to find log files, knows where to find the config files. Then you set your specific SSH parameters, the username that you want to connect the nodes to, and the password. And we recommend you set skip s3 equal to true so it does all the collection locally to the machine, doesn't try to push files up to S3. If there are extra credentials required for CQLSH, if you have security, username, password, there's parameters to set the CQLSH username, password. If it's a DSE environment, setting is DSE to true. And then there's other parameters. It's not a huge file. There's maybe 25 different parameters you can set. There's some SSH, there's some SSL parameters. So for more hardened environments, there are parameters that have been provided that you can set so that they can actually connect and do the collection. It's pretty self-explanatory. It may take a few iterations, but I'm sure you'll get it. So then running the DS collector. So now you've got the config file set. And it's pretty simple. There's just some different options you can feed to the DS collector command. -T is a test mode, so it'll actually test SSH before it actually tries to collect anything. -V is verbose. It'll give you a lot more information. -F is the name of the file. And then -N is the name of the node that you're going to connect to. So that's the first one was for a test as the T. So then you can actually run the collector for just one node. There's a -D option that says just run it for one node, the node that's named here. So that's lets you just test it for single node. Like if you have 50 nodes, you got a problem, you just want to try it for one. If there are any issues, you'll see there's these messages that come up. It'll say not okay if there's a problem. And so then if there's any not okay messages in the step, there's a troubleshooting page that you can look at. It's pretty good. It's pretty thorough. I haven't had a problem yet that's outside the troubleshooting page, so I'm sure you'll figure it out. And then, so then once you've got a clean run for one node, then you can run it for all nodes. You just -X and then -F, -N. The contact node, you remove the -D, which means do it for one node. So it'll do it for all nodes in the cluster. And it'll bring all the tarballs to that collection machine. You can run for a subset of nodes. If you have 1,000 nodes in your cluster, you only want to get 50 of them. You can put a list of host names into this collector.host file, and then run, instead of giving it a single host name, you give it the name of the host file. Run for a subset. So then once this is run and it's collected all the tarballs, they're found under /tmp/datastax. So there'll be a separate tarball for every single node that it collected from. It'll be the host name _timestamp.tar.gz. So then, now to prepare for the Montecristo step, with a different machine, you would move those files to the machine where you're going to run Montecristo. If it's the same machine, you can stage them on the same machine. Or you can push them up to datastax support, or you can push them to a partner to run Montecristo for you. So that's another thing. We have our customers do this process, push the gzips to us, and then we run Montecristo. we'll do a formatted report. It's another process. So okay, so now we've got the collected tarball files, one from each node. Now we go to stage 2. We generate the health check report with Montecristo. That's the next step. So diagnostic tarballs, Montecristo, we're going to produce our report. So for Montecristo, we need a Linux or OS machine, not one of the cluster nodes. It requires Java 8. We need Docker desktop installed. We need Hugo, Zip, and JQ installed packages on the machine. And the machine needs to have access to the tarballs, so we need to get the tarballs to that machine. And then, so on GitHub, there's the under datastax-labs repositories. So we're going to cover the install at the end. I was just going to, like, let's assume it's installed. Now let's run Montecristo. And then we'll talk about installation later. It's not a huge deal, but I just wanted to make sure I got to do this. So we created a DS discovery directory somewhere on the machine that where we're going to put the tarballs. We're going to stage our tarballs. Under that, we're going to create our subdirectory with our issue number that we created earlier. So you'll have a directory structure that looks like this with your tarballs in it. And then I created another directory right underneath the issue directory called extracted, and I uncompress these tarballs into that extracted directory. Just the whole process works better when we do it this way. And then I rename the timestamp names into just the node names. So it's a nice list of node names, and then underneath each one of those node directories is the full set of files that have been collected. And then because the Montecristo used those names, those directories in the documentation, so it's good to extract them like that. So then, so now we've got the file stage. We just run Montecristo. We go into the Montecristo directory, run.sh, these parameters minus d minus c, the location of our files, and then the last parameter is the name of the artifacts directory that it creates. Run that, and then it asks you some questions. Do you want to copy the artifacts? You say yes. Decompress again, we say no. Run the conversion process, yes. And then it asks the same question again, we say yes. So once we get through that, it runs for several minutes, maybe 20 minutes. Depends on how many nodes you're running it for. But when it's done, and I'll show you the picture of what it looks like. You get this message, it comes back and it says the web server is available, and it gives you the web server location, localhost. And then you just take a web browser, connect to that host name with the port number that it gives you, and it pops up the report. So it's a huge report. It's an HTML format. So then from there you can print it as a PDF, and then you can use Word to convert the PDF to Word. This is the process I use. It's kind of cumbersome, but it works. And so that was. Let me see if I can get show you the file.
Are you going to do a live demo?
I do not. Do you want me to?
Feel the thrill, man.
If we have time, if we have time, I'll try it. But John scared me this morning. I kind of took it off the table. I'm game to try it. But anyway, let me talk about installing it. So to install Montecristo, like we said, Linux or Mac, it needs to have the diagnostic tarballs on it. Can't be a cluster node. Get the you get the source from GitHub. So now you have to install several dependencies for this to work. Mentioned earlier. You need Java 8. You need to verify it. On my Mac, I had to change my Java version, change my Java home to point to Java 8. Then there was a problem with Gradle. I had to do a Gradle fix. I had to add Gradle properties file and put my Java 8 version in it. And so this is my Mac. I've got so much stuff on it. This is what I had to work through to get it to work. But this was the hardest part, just getting Gradle to work. So I figured I should put my experience in here. But once I did get the Gradle fix in place, that fixed the problem I had. That was my big hang-up. And then you have to make Hugo once you've installed it. So there's a script under Montecristo that you use to make the Hugo web server. And then so this was interesting. if you're doing a DSE Montecristo report, it's going to try to interpret the metadata in SS tables. So you do have to extract some of the DSE libraries and put those down under Montecristo. So it'll still work without this, but if you wanted to interpret the metadata for DSE clusters, you do this step. So you have to download this specific version, 6.8.17 of DSE, and then pull these, 7 jars out of that distribution, copy them down to underneath Montecristo DSE stats converter /labs, and then it works. So that was another little PR battle I had to get that figured out. But it's pretty simple if you know. I had the wrong version. I'm like, oh, let's get the latest. Totally didn't work. You have to have 6.8.17 to work. So this is kind of like a little treasure map. If you're going to attempt this, this presentation is on GitHub, so definitely you can follow this, and you shouldn't have a problem if you try. So helpful links underneath the DS collector is on GitHub under diagnostic collection. There's another one called DataStax DS support. Diagnostic collection is not that one. It's the one that's called diagnostic collection. And then Montecristo is under datastax-labs on GitHub. And then Rhinosaurus if you need help. So this was the overall process. So do you want me to try to do a demo? Is that okay?
So look at John. He's more excited than you are.
All right, let me see. I restarted the whole system so I could.
It's like high stakes gambling, you know?
All in.
So let's see. It's underneath Cristo. So let me get out of my presentation the command. Back and find. You know what I mean? I think I used a different machine number to see the machine number. Mine is called. Oh, it's under the discovery. Here, I'll show you my discovery directory. So I've got a directory called DS Discovery. And so under this directory, I should make that bigger. Okay, you see that better?
There you go.
Okay. So I've got several things this was my demo. So this read run. I have a lab server that I used. So under this Rhino lab, you can see this was my raw tar balls, and then under extracted, are the unzipped tar balls. So there's DS1, DS2, DS3, those are my 3 node names. So I'm going to use that Rhino Lab 2024 10.5 issue number. Cristo.
Hey, stuff's doing it.
And
Working great. Yeah. Yeah, I'm jealous. I'm just trying to figure out what's different. I'm watching.
Difference with that.
Yeah. One love bump.
Not sitting your dependencies.
That's the lesson.
That's what we learned.
Yeah. In your defense.
Where you learn the 6 Ps.
Hang with Jordy. He is your lifeboat.
That's an hour mission.
So this hopefully, I need to put this as my. Okay, so that should be command.
There is an hour missing in extracted.
Oh, thank you.
It's exactly.
Thank you. Okay, let's see if that works. Here's the questions. Do you want to copy them? Yes. Let's not compress again. Let's do the conversion process. Hey, my demo's working. Woo!
Flex.
Uh-oh.
Next again.
One more.
Yeah.
Is this a good time to talk about grading the project? No?
Yes.
Yeah.
I've been spending,
Okay, so that's pretty fast. So it says the web server is available, so let's go to that address.
I keep bringing up the awkward conversation, so I'm just gonna keep it going.
So we'll pull up that.
Wow.
And so here's discovery findings, and so then we go to the draft report. So here it is.
Yay.
Look at that.
Woo!
Wow.
That's still going. Data model.
So this is the recommendation.
Yeah.
It literally gives you a book. Yeah.
So it's a huge report. So
There's a lot of change out. The part where it says materialize and use it, she's always say don't use it.
yeah, right. That's right.
It's mine. I wrote the rule.
But this is kind of cool where it does organize like immediate issues, near-term changes, and then long-term changes. So those are good. That's helpful, like when you're talking to customers, and saying, like, this is stuff you take care of right away. So then, what I'll do is I'll PDF this and then convert to Word, and I'll put in my own stuff. Some stuff you can take out. But yeah, so that's it. So I'd say, and let me go back to my presentation. Let's see. We're here. Oh, yeah. So this presentation I uploaded to my GitHub, Dave Herrington. It's H-E, not H-A. There's a different guy's picture, H-A. But I have a directory called, Community Over Code. And under that is this presentation. So if you're trying to do this, I recommend getting that and using it as your guide. And I think you'll be able to, all you guys are way more smart than me on this stuff, so you'll be able to figure it out. But I think just, using mine as a guide at least gets you through the easy mistakes that I made. And if you have any issues, feel free to contact me. I'm on LinkedIn. I'm LinkedIn with several of you, but feel free to link in with me, Dave Herrington, Herr. GitHub, Dave Herrington, my email, my phone number. So please feel free to call anything I can do to help you guys. I really appreciate you having me here and you coming to my presentation. And hopefully it wasn't too boring. And for the last one, because I'm standing between you and beer. That's a really tough place to be. So any questions about this? I'm happy to take any questions.
Does this expect like a specific layout of configuration to work, or would it work with like a standard open source Cassandra?
It'll work with open source. It's just the configurations can just be slightly different in where log files get kept and where the Cassandra install directory is, and that's what that collector.conf file has settings where you can specify where those are located on nodes. I think it would get confused if nodes had different layouts, but as long as every node is the same, the log files are var log Cassandra or some other standard location for you, then you can specify that in the configuration file and it will find them. So that's, if your default, there would be less to configure, but you can definitely tailor the config file and it'll find all your stuff. So, and I think the sudo is kind of key though, making sure that the SSH user has sudo capability without a password on the nodes so that the collector can actually get like the OS information. There's a lot more information it can get. Because if it connects as Cassandra, if Cassandra doesn't have sudo, it won't be able to get some of the OS configuration stuff. So there'll be some blank spaces in that board. So, yeah. Any questions? Does anybody know how we're going to get our answer? Have your information?
Information said if you don't have an armband, just put your badge and share it at the door, and they should be able to let us in.
I have an extra one.
You did? Oh, sweet. Thank you. All right. That was it.
I would give it a +1.
It was so funny, but I went back to class and I was like, I'll take a +1 just in case. And they were like, no, we're out.
Yeah.
I was like, I can still try.
Well, that's what you can get it with your badge now. They
Yeah.
ran out of everything.
Yeah. Oh, so now I'm +1.
All right. Well, thanks, guys. And have fun tonight. We'll see you up there.
Thank you.
Thanks again for
Thanks,
coming.
Dave. This